Hello, Terry.
Sir,
Um, Next, today onwards, we'll start the motion in straight line.
okay, sir.
Okay. In motion in straight line, we are having these are the topics.
Okay, sir.
Write down. Write down. Okay, na? Fine.
Yes, sir.
Okay. These are the topics are there. Okay, na? Fine. Now, out of these, especially either in MSET or in JEE mains, okay, these topics, okay, kinematic equations of motion, motion and gravity, graphs, and then this one. These are the important topics. Give first priority to this one, and then second priority to graph, and then third priority to this one, average speed, average velocity, and then instantaneous velocity. Okay, na?
Okay, sir.
Fine.
Fine, sir.
These are the topics. Okay. Before that, okay, in entire this first year or class 11th, we'll discuss about mechanics. These mechanics is divided into three types. First one, it is kinematics. Okay. Next, it is dynamics. Major part, it is dynamics only. Okay. And then finally, it is thermodynamics. With respect to heat, we'll discuss these three parts. First, we are going to discuss about the kinematics. Kinematics is a branch in physics which deals with the properties of particle. Properties of particle. By considering that particle is in motion. That means either in presence of external force or internal forces. By somehow particle is in motion. Properties of particle such that particle is in motion. Particle is in motion. Okay, na? Fine.
Okay, okay, sir.
Okay, fine. Now, you can see, okay, particle is in motion. That means whether the force is acting on it or not, it is irrelevant. Or by what the particle is in motion is irrelevant to us. Okay. Whenever the particle is in motion, then we need to find the properties of the particle. Here, properties of the particle means we can say distance, displacement, okay, speed, velocity, acceleration, etc. These are the properties we need to find. Okay, fine.
Okay, sir.
These are the properties we need to find. So, entire in this chapter, we are going to study about the properties of the particle without consideration of the force. Dynamics means here also we'll find the properties of particle. Properties of particle such that whenever we apply a force, then particle will be in motion. Okay, particle is in motion. Okay, thermodynamics means by heating a substance, what are the properties of the particle? That we are going to define. Okay, na? Fine.
Okay, sir.
Okay. In this kinematics, we are having the 3 chapters. In this kinematics, we are having the 3 chapters. Number 1, it is motion in a straight line. Motion in a straight line. Number 2, motion in a plane. Here only we'll have the vectors. Already we discussed vectors, right?
Yes, sir.
Okay. And then finally, we are having the relative motion. We are having the relative motion. Okay. Fine. These are the topics are there. First, in the motion in a straight line, in this chapter, firstly, we are discussing that we know that 7 fundamental properties are there. That is mass, distance, and then time. Okay. And then number of degrees of freedom, absolute temperature, and then electric current and luminous flux. These are 7 fundamental properties are there. Mass is defined as amount of substance, or you can say matter. Contained in a given volume of an object. Given volume or area of an object. Okay. Of an object. Fine.
Yes,
Is
sir.
it okay?
Okay, sir.
Fine. Okay. Mass. Next, suppose let us consider when we can say that particle is at rest. If the particle or object, anything it is same. If the particle or object does not change its position for a time t, then we can say that particle is at rest. Okay. Particle is at rest. Okay, fine. Suppose,
Okay.
let us consider, okay, I'm having an XY plane. XY plane. Initially, particle is at point A. Is at point A. After a time of 1 hour, if the particle is at A only, then I can say that particle is at rest. Okay, na? Fine.
Okay, sir.
Okay, na?
Okay, sir.
Fine. Suppose, for example, okay, suppose let us consider in any place bus depot. In the depot, buses will come at 12 o'clock. Same that bus, okay? Same that bus, okay? Up to 4 a.m. will be at rest. Can I say
Yes, sir.
12 to 4? Okay, na?
Okay, sir.
Is it fine?
Yes, sir.
Okay, fine. Next, motion. When we can say that particle is in motion. If the particle changes its position, if the particle changes its position, with respect to time, then we can say that particle is in motion. Okay, na? Is it fine?
Okay, sir. Yes, sir.
Okay, fine. Particle is in motion. Suppose, for example, whenever we are operating mixie, or if AC is switched on, then I can say that the device is in motion. Okay. Suppose
Yeah.
motion of a fan when fan is switched on. If it is switched off, then we can say that fan is at rest. Okay, na?
Okay, sir.
Otherwise, motion of a bus from morning, suppose 5 a.m. to at least 3 p.m. In between this time, bus will be in motion only. Right?
Yes,
Can I
sir.
say or not?
Yes, sir.
So here, as the title of the chapter says, motion in a straight line. That means we are considering particle is moving only along one axis, either x-axis or y-axis. Any one axis only we are considering. After this chapter, we are having motion in a plane that is in 2 dimension. Okay, na? Fine.
Okay, sir.
Okay, fine. We are having the 7 fundamental properties. There are 7 fundamental properties in physics. Okay, you need to remember these 7 fundamental properties. Number 1, it is mass. Number 2, length. Number 3, time. And number 4, number of degrees of freedom. Number of degrees of freedom. And number 5, it is absolute temperature, or we can say it is normal temperature. Okay. Either you can say absolute temperature or temperature. Number 6, it is electric current. And number 7, it is luminous flux. Okay, na?
Okay, sir.
Mass will indicate with either small m or capital M. Length will indicate with L or S, X, Y, or small r. Time, it is T. Number of degrees of freedom as small n. Absolute temperature as T. Current, either small I or capital I. Luminous flux, capital I, or phi. Okay, na?
Okay, sir.
Fine. I think
Sir,
you don't know number of degrees of freedom and then luminous flux. Only these two. Remaining quantities you might studied up to 10th class.
yes, sir.
Number of degrees of freedom means, suppose I'm having an particle like H2 molecule. Hydrogen molecule is there. These hydrogen molecule can move along x-axis, y-axis, and z-axis. Right? Is it fine?
Fine, sir.
Okay. That means a substance can move either x-axis or y-axis or z-axis. Suppose apart from these axes, okay, suppose if I consider like molecule like H2SO4 or PCl5, then apart from this, okay, it will vibrate like this. Okay, na? Fine, na? It will vibrate. Absolute temperature, okay, temperature will be Celsius, Kelvin, okay. So for Kelvin, we can indicate with K. Temperature means we'll indicate with T. Okay. SI
Okay,
unit of temperature will be Kelvin. Even I agree with that. Okay, now. Even Celsius also will come down. So that's why temperature will indicate with capital T. So it can vibrate in any direction. So number of degrees of freedom means minimum number of degrees or minimum number of axes which are used to explain the motion of a particle. Okay. Minimum number of coordinates or degrees that are required to explain the motion of a particle. Right?
okay, sir.
Fine. Suppose,
Yes, sir.
for example, you can see in every home, okay, there will be one son or daughter. They will roam in and around the room along x-axis and y-axis or z-axis. Then usually mother or father, they used to explain their motion. Right?
Yes, sir.
What they will say, why unnecessarily you are roaming here? Right?
Yes, sir.
Generally in Telugu, what will say it is, ఎందుకు అట్లా అడ్డగాడిదలా తిరుగుతున్నావు. అవునా?
Yes, sir.
Right. Okay. That can be described by this quantity, number of degrees of freedom. right? Next, luminous flux. Luminous flux. It is defined as amount of energy absorbed or emitted. Amount of energy absorbed or emitted per unit area and per unit time can be called as luminous flux. Can be called as luminous flux. Okay. Suppose let us consider in any room, we'll have the light. Suppose tube light or any low power consumption bulb will be there. Right. Near to
Yes.
that bulb will have light energy will be absorbed by the floor.
Yes, sir.
Light energy will be absorbed by the floor, right? Okay, na?
Okay, sir.
So, with respect to floor, I can say energy absorbed. With respect to source, I can say it is energy emitted. Okay, na? Energy emitted. So, energy absorbed or energy emitted by area multiplied by time. As the area increases, this luminous flux will be decreases. Okay, na? This
Okay,
luminous
sir.
flux will be decreases. And as the time taken increases, luminous flux is also decreases. Okay. Fine.
Okay, sir. Yes, sir.
Okay, fine. Okay, fine. These are the 7 fundamental properties. Okay, na? Previous pages wrote this page.
Yes, sir. This page completed.
This one.
This one also completed, sir.
This one.
I have to write, sir.
Oh, okay, right now.
Done, sir.
Okay, fine. Next. Okay. First topic in the motion straight line, it is distance. Distance. This distance will indicate with D or S or L or X or Y. Okay. Fine.
Yes, sir.
Fine.
Yes, sir.
Okay. Next. Suppose let us consider this is point A. This is B. Okay. A is at. Okay. Suppose let us consider A is Hyderabad. B is Bangalore. Okay. Now, if a person starts from Hyderabad, okay, and reaching towards the Bangalore. Now, I want to find what is the distance. Distance means, okay, it is the path length in which path he is moving, right? He can move like this. He can move like this, or he can move like this, right?
Yes, sir.
So, in which path he is moving, that is the important. So, distance it is defined as path traveled by an object. Path traveled by an object from initial position to final position. From initial position to final position. Right? A is called the initial position.
Yes, sir.
B is the final position.
Yes, sir.
Okay. Distance does not have any direction. Okay. Distance does not have any direction. It can move in any direction. Okay, now.
Okay, sir.
It can move in any direction. Okay. In any direction, it is distance is defined as path traveled by an object from initial position to the final position. From initial position to the final position. Okay, na? Fine.
Okay, sir.
So, distance can be represented by or denoted. Represented can also be called as denoted by either with the letter D, S, L, or X, or Y. Distance can be represented by this one. Okay. Next. SI unit of distance. SI unit of distance is meter, which will indicate with M. Meter is not a scientist name, so we'll indicate with small letter. If you see, in 10th class, you might study current. SI unit of current, it is ampere.
Yes, sir.
Ampere is the name of the scientist, so we'll indicate with capital A. So we'll indicate with capital A, like that. And
Okay.
previous unit of distance is centimeter, cm. Okay. Cm means centimeter. Okay, na?
Okay, sir.
Fine. And we know that relation 1 meter equal to 100 centimeter, or 1 centimeter equal to 10 power minus 2 meter. 10 power minus 2 meter. Okay, na? Fine.
Okay, sir.
Okay, fine. Now, distance, that one. Next one comes to the displacement. Next comes to the displacement. Displacement is defined as shortest distance
Short.
traveled by the object from initial position to the final position. Here, write down one point. Distance is a scalar quantity. Distance is a scalar quantity. Okay, na?
Okay, sir.
Okay, fine. Fine. Next, displacement. Displacement, it is the shortest distance. Shortest distance traveled by the body or particle or object, anything, by the object from initial position to the final position. To the final position. Okay, na? Okay, na? Fine. So,
Yes, sir.
next, displacement is represented by R or S. Okay, na? Displacement is represented by R or S. By definition, you can see displacement, it is the shortest distance. So, SI unit of displacement. SI unit of displacement. Displacement is meter only because it is shortest distance. Right? Fine.
Yes, sir.
Okay, fine. Next. CJ's unit of distance. Sorry, CJ's unit of displacement is centimeter. For meter, will indicate M. Centimeter, it is cm. Okay, na?
Okay, sir.
Fine, na? Okay, na? Fine.
Fine, sir.
Okay, fine. Next. Centimeter. Okay. And displacement is a vector quantity. Always it will move from initial position to final position. Is a yes, ma? Tell anything happen, huh?
No, nothing, sir.
Okay. Fine. Displacement is a vector quantity. It will always act from initial position to the final position. Okay, na? Fine. That is what
Okay,
on the displacement. That is what on the displacement. Now we'll see the examples to find how we'll find the distance and displacement. Okay. Examples of distance and displacement. ఓకేనా?
Okay, sir.
Fine. Now, first one is, if a particle is moving in a circular path of radius r, here I am having a particle A, such that OA equal to R. OA equal to R. Okay. Fine. Now, in this case, I need to find distance and displacement. Distance and displacement. Okay.
Okay, sir.
Okay. Na? Fine. So that means particle starts from A, after some time, again it reaches to point A. Okay. Na? That means particle completed one rotation.
Yes, sir.
Okay. Suppose if particle completes one rotation, you can see distance means path traveled by the object from initial position to final position. Here path
Yes, sir.
traveled means nothing but circumference of a circle. Okay, na? Is it fine? Circumference of a circle. What is the formula?
2 pi r, sir.
2 pi r. Very good. 2 pi r.
Yes,
Now,
sir.
displacement means, okay, initial position is A, final position is also A. Right?
Yes, sir.
So, that means final position minus initial position. Since final position and initial position are same, so can I say that displacement equal to 0?
Yes, sir.
Okay, na?
Okay, sir.
Fine, na?
Yes, sir.
Suppose this is the case for one rotation. If particle completes two rotations, what is the distance traveled with particle? What is the distance traveled by particle? For one rotation, it is 2 pi r. Okay. For one rotation, it is 2 pi r. For two rotations, what will be the distance? 2 into 2 pi r. Right?
Yes, sir.
Can I say?
Yes, sir.
Fine.
Fine, sir.
Okay, fine. Suppose three rotations.
3, 2.
3 into 2 pi r. Like that, for n rotations, I can say distance equal to n into 2 pi r.
Yes,
Displacement?
sir.
0. Right?
0. Yes, sir.
Okay, na? Fine. Now, second example. Now, with a radius r, particle moves in a semicircle. Okay. Moves in a semicircle. That is, particle is moving from A to B, having OA equal to R and OB equal to R. Okay, na? Fine.
Okay, sir.
Okay, fine. Now, that means distance equal to path traveled by particle, that is A to B. Na? It is just like circumference of a semicircle.
Yes, sir.
Circumference of a semicircle. What is the
Yes, sir.
circumference of a semicircle?
180.
Huh? Circumference.
180.
See,
Far,
hmm?
far none, sir.
Circumference of a circle means 2 pi r. Circumference of a semicircle means we
Pi
can
R.
write as pi r.
Yes, sir.
Okay. Displacement. Displacement.
G.
Okay.
0.
That is equal to displacement. A is the initial position.
Yes, sir.
Initial position. B is the final position.
Yes, sir.
Okay. Particle is moving from A to B along the circumference of a semicircle. Right?
Yes,
So
sir.
instead of this, okay, shortest path it is A to O and O to B. Okay, na?
Yes, sir.
So that is displacement. It is AO plus OB. That is nothing but 2R. Okay, na?
Okay, sir.
Fine, na?
Fine, sir.
Okay. For your understanding, I'm saying, okay, value of pi means it is 3.14.
Yes, sir.
Value of pi means 3.14. Okay.
Okay, sir.
So distance it is 3.14 into R. Displacement will be 2R. Whatever be the value of R among distance and displacement, which is greater?
Distance.
Distance, right? So in
Yes,
our
sir.
definition of displacement, displacement it is the shortest distance, right?
Yes, sir.
Is it fine?
Fine, sir.
Next, another example. Here. Previous pages wrote,
Yes, sir.
wrote na? All
Yes.
these pages completed na?
Yes, sir.
Next, number 3. If a particle is moving in the shape of a square, in the shape of a square, let us consider initially particle is at A and then it is moving in counterclockwise direction. Now I need to find whenever it completes one rotation, what is the distance traveled? Distance and displacement. Let us consider side of a square as A. In a square, we know that all the sides are equal.
Yes, sir.
Okay, na? So particle
Okay, sir.
travel from A to B, B to C, C to D, D to A. So what is the distance traveled? That is AB plus BC plus CD
CD,
plus DA.
DA.
That is nothing but 4a.
Yes, sir.
Okay, na?
Okay, sir.
Is it fine?
Fine, sir.
Okay, fine. Next, displacement. Initial position is A. After one rotation, again particle reaches to A.
Yes, sir.
Right? So, initial position and final position are same.
Yes, sir.
So, what we can say that it is, displacement will be 0.
Yes, sir.
Okay, na?
Okay, sir.
Is it fine?
Yes, sir.
Okay, fine. Next, another example, same in the square only. If a particle moving in the form of a square. Suppose particle moves from A to C. Side of a square is A. Okay, up
Okay,
to
sir.
here. Now, what is the distance traveled?
A to B, B to C.
That means AB
To
plus BC.
yes, sir.
Very good. Now, displacement.
To initial point and final point is different, sir.
Initial point
And
is A.
final point are different.
Where is the final point?
C.
Huh?
At C, sir.
At C. Very good. So, what is the distance between A to C? What is the shortest distance? Not distance, shortest distance.
Right. Di
Hmm?
diagonal.
Which one?
Diagonal.
Louder.
Diagonal.
Very good. Okay. Right. Diagonal. By using Pythagoras theorem, can I say that AC square equal to AB square plus BC square? Can I say? Okay, na?
Yes, sir.
So it is A square plus A square. That is nothing but 2A square. The AC equal to root 2A. Can I say? Right.
Yes, sir.
Okay, na? So displacement will be root 2A. Can I say?
Yes, sir.
Okay, fine. Suppose, let us consider I am having the geographical directions like north, south, east, and then west. Okay, fine.
Okay, sir.
Okay, fine. Suppose, let us consider I am having a particle here at point A. This is O. Particle travels a distance 8 meter to the O and travels a distance from O to B, 15 meter. Now I want to find what is the distance traveled and what is the displacement. What is the distance traveled and displacement? Okay, na? Fine. Is it okay?
Okay, sir.
Okay. So, which is the initial position?
A, sir.
Very good. Which is the initial final position?
B, sir.
B. So, distance means how much?
AO plus OB.
AO plus OB. Very good. That is 23 meter.
Yes, sir.
So, A is the initial position, B is the final position. So, displacement, which is the displacement?
A to B, sir.
Here, like this. Okay, na? Fine. So, how to find this AB distance?
Pythagoras theorem, sir.
That is under root 8 square plus 15 square. If you remember, I told trios, right?
Yes, sir. 17.
Right? 17. Directly we can write now.
Yes, sir.
So in this case also, we are having that displacement is less than the distance.
Yes, sir.
Okay, fine. Another example, it is, let us consider Cartesian coordinate system. That is XY plane, XY plane. Okay, na? In this XY plane, I am having a point A. X1 having the coordinates as X1, Y1. And I'm having a point B having the coordinates X2, Y2. Now let us consider particle is moving from A to B like this. Particle is moving from A to B. Then we need to find distance and displacement. And then displacement. Right?
Yes, sir.
Okay, na?
Okay, sir.
Fine. Distance means here in mathematics, we know that distance between 2 points, that
Yes,
is
sir.
under root x2 minus x1 whole square plus
Plus
y2 minus
Y2
y1 whole
minus.
square.
Yes, sir.
Right? Is it fine?
Yes, sir.
Is it fine?
Yes, sir.
Okay. Displacement. This is the shortest distance only, na?
Yes, sir.
So, this is also x2 minus x1 whole square plus y2 minus y1 whole square. Okay, na? Fine, na?
Okay, sir. Yes, sir.
Is it okay?
Okay, sir.
Okay. So, in this case, if you observe, in this case, we are having that distance equal to displacement.
Yes, sir.
So combinedly, I can say that by all these cases, I can say that displacement is less than or equal to distance.
Yes, sir.
Or we can say that displacement by distance. Displacement by distance less than or equal to 1. Okay, na? Is it fine?
Okay, sir.
Okay, fine. Okay, na? Previous pages wrote.
Yes, sir.
Display, that is up to here it is distance and displacement.
Okay, sir.
Next, it is speed. Will indicate with C. Speed will indicate with C. Speed is defined as distance traveled by object in a time interval. Distance traveled by an object in a time interval. Okay. Time interval means in a particular time t. In a particular time t. Okay. So that's why we'll write as speed equal to distance traveled by time taken. Distance traveled by time taken. Okay. Fine.
Okay, sir.
Suppose I'm having the two walls. This is P, this is Q. If two persons are walking from P to Q, okay, are walking from P to Q, distance is same. Let us consider two persons as A and B. A and B. A is taking a time 5 minutes and B is taking a time 8 minutes. Then whose speed is more?
B, sir.
Huh?
Yes, sir. Yes, sir.
A na, right?
Yes, sir.
The person whose time is less, time taken will be less. Okay. That person's speed is more. So speed of A is greater than speed of B. Write on this one.
Done, sir.
Okay, na? Completed?
Yes, sir.
Now, speed means distance traveled by time taken. So, I can say that both distance and time, it is a scalar quantity. So, speed is a scalar quantity. Scalar quantity. SI unit of speed is meter per second. And CGS unit of speed is centimeter per second. Okay, fine.
Okay, sir.
Okay, fine. Next, speed. And then velocity. Velocity will indicate with V. Velocity will indicate with V. Velocity is defined as rate of change of displacement, rate of change of displacement with respect to time. With respect to time. Okay. That is V equal to velocity equal to. Otherwise, we'll write velocity. Velocity equal to change in displacement. Change in displacement by change in time. Generally, this displacement will indicate with R. So, change in displacement means will indicate with dr, and change in time will indicate with dt. Okay, na?
Okay, sir.
Change in displacement will indicate with dt. So, V equal to dr by dt. Change in displacement means, suppose, let us consider xy plane. Initially, particle is at O. After some time, it had moved to 5 meters. Okay. What is the change in position? What is the change in position? 5 only, na? This
Yes,
is
sir.
final position. This is initial position.
Yes, sir.
Okay. That means final position minus initial position. 5 final time minus initial time. Okay, na? Is it
Okay, sir.
fine?
Yes, sir.
Okay, fine. Suppose velocity equal to displacement by time. If and only if initial displacement, initial time equal to 0. Initial displacement and initial time equal to 0. Then only we can say that velocity equal to displacement by time. Otherwise, it is change in displacement by change in time. Okay, na?
Okay, sir.
Fine. Is it fine?
Yes, sir. Fine,
Okay.
sir.
Now, you can see Suppose if a particle starts from rest, okay, then we can say that it is initial displacement is 0. Okay na?
Okay, sir.
అంతే కదా? Is
Yes,
it
sir.
right? Okay. Okay, fine. Since velocity equal to change in displacement, so I can say that velocity is a vector quantity. Velocity is a vector quantity. And SI unit of velocity is meter per second, because SI unit of displacement means meter, na? SI unit of displacement is meter. Okay, na? Fine. So, SI unit of velocity is meter per second, and CGS unit of velocity is centimeter per second. Centimeter per second. Okay,
Okay, sir.
fine. And we are having an special unit of velocity is kilometer per hour. Special unit it is kilometer per hour. That is, now we need to convert kilometer per hour to meter per second. Okay, na? I can say that 1 kilometer per hour, I need to convert into meter. 1 kilometer means, can I say it is 1000 meter?
Yes, sir.
1 hour equal to 60 minutes, and 1
Yes,
minute
sir.
equal to 60
60
seconds.
seconds.
So it is 3600 seconds.
Yes, sir.
Okay, na?
Okay, sir.
Fine, na?
Fine, sir.
So it is, upon calculation, we'll get 5 by 18. Okay. 1 kilometer per hour equal to 5 by 18 meter per second.
Okay, sir.
5 by 18 meter per second.
Second.
Okay, na? Fine. Next. Similarly, we can convert 1 meter per second equal to 18 by 5 kilometer per hour. Suppose example, convert 72 kilometer per hour to meter per second. Okay. Convert this. 72 kilometer per hour means, can I write as 72 into 5 by 18 meter per second?
Yes, sir.
So
20.
it is 20 meter per
20
second.
meters.
20 meter per second. Similarly, convert 108 kilometer per hour to meter per second. Okay, na? Convert 108 meter per second. అంటే 108 kilometer per hour equal to 108 times 5/18 meter per second. Okay. Fine.
Yes,
Is
sir.
it okay? Is it
Okay,
okay?
sir. Okay, sir.
Okay, fine. So, upon calculation, we'll get it as 30 meter per second. 30 meter per second. Okay, na?
Okay, sir.
Fine. Next, acceleration, which will indicate with A. Acceleration is defined as rate of change of velocity. Okay. Acceleration is defined as rate of change of velocity. Okay. It is defined as rate of change of velocity with respect to time. With respect to time. Okay. Fine. Huh? So
Yes,
acceleration
sir.
equal to acceleration A equal to change in velocity by change in time. Velocity will indicate with V. Okay. Velocity will indicate with V. So change in velocity, can I say dV? Change in time is dt. Okay, na?
Okay, sir.
So it is A equal to dV by dt. Change in velocity means we can say final velocity minus initial velocity, right?
Yes, sir.
Okay, na? Same as like before. You can see velocity, we wrote it as dr by dt. And acceleration, we wrote it as dv by dt. In the definition, we told that it is rate of change. Observe here. Okay, this one. If any quantity is varying with respect to time, we can call it as rate of change. We can call them rate of change.
Rate of.
Okay. If any quantity is varying with respect to position, okay, afterwards you will get the potential energy. I think you know potential energy, right?
Yes, sir.
So that is, we'll write as F equal to minus du by dr. Here, potential energy is varying with respect to the position. So this we can call potential gradient. This we can call potential gradient. Okay, na?
Okay, sir.
Okay, na? So rate of change
Okay,
means
sir.
any quantity. Here it is in the velocity definition, it is displacement. Rate of change of displacement with respect to time. Okay.
Okay, sir.
And then this one, acceleration means rate of change of velocity. Okay, na? Fine. Since it is acceleration means change in velocity by change in time. Velocity is a vector quantity, right? Velocity is a vector quantity.
Yes, sir.
So we can say that acceleration is a vector quantity. Okay, na? Fine.
Okay, sir.
Okay. SI unit of acceleration. SI unit of acceleration is velocity means meter per second. Time is second. So it is meter per second square. Similarly, serious unit of acceleration is centimeter per second square. Okay, na?
Okay, sir.
Fine. Let us consider example. Let us consider example. That is, if a person is climbing up a mountain, is climbing up a mountain, which is at a height h, and then coming downwards. And then coming downwards. Okay. Fine. Here,
Fine, sir.
increase the height and then decreased. Here it is. Okay. Displacement is nothing but this one only. Okay, na?
Yes, sir.
Okay. Suppose if he reaches the same position, then I can say that displacement is 0. For this situation, I need to draw graph between velocity versus time and then acceleration versus time. Okay.
Okay, sir.
First, from A to B, as the height is increasing, what will happen? The velocity will be decreases. At the maximum height, okay, velocity will be 0. Right?
Yes, sir.
That means here velocity is decreasing. Okay. Initially at point A, it is 0. Okay. Velocity will be decreases. This is point B. Okay. And then
Okay, sir.
increases. Okay, na?
Okay, sir.
Fine, na?
Fine, sir.
Is it okay?
Yes, sir.
Okay, fine. Acceleration from O to B as velocity is decreasing, acceleration will be negative. Okay, and it is a constant. And thereafter it is increasing like this. Okay, this is the path O to A. Okay, here it takes a time T1, this is T2. So during the path T1, acceleration is negative, right? And this point, it is T2. Fine?
Yes, sir.
Okay.
Okay, sir.
Up to here, remember, acceleration in the time. Tomorrow we'll discuss about the uniform motion, non-uniform motion, average speed, average velocity, and then instantaneous velocity.
Okay,
Okay,
sir.
fine.
Fine, sir.
Is it okay? Tomorrow also
Okay, sir.
we'll meet at 11 o'clock, same time.
Okay, sir.
Okay. If there is any changes, I'll inform you.
Okay, sir.
Fine.
Fine, sir.
Mm.